We're still in the same section 5.2, but instead of doing long division, we're going to learn this new method called synthetic division. And normally I have this like page of steps, right, to show you and explain how to do it. But instead of giving you a page of steps for you guys to copy down, I'm going to jump right into an example. And this is an example that we did with long division. Let's move the long division steps out of the way, and let's do this one with synthetic division. Now, the first thing, just like in long division, you want to reorganize your polynomial in standard form, which means from highest exponent down to the constant itself, and you want to represent every single power, just like we did in long division. So we're going to begin with the highest exponent term, which is 2y to the third. So let's write that first, 2y to the third. And then we have the next highest exponent term, which is y squared, which is negative y squared. So that's what we're going to write, negative y squared. And then we're looking for the y. And notice that there is no y, right? There's no y. So what am I going to put? I'm going to put plus 0y. And then at the very end, the constant plus 25. So step one, whether it's long division or this new method synthetic, to reorganize it in standard form, highest exponent down to the constant. If you have any missing terms, like we had the missing y, we put 0y. That means that there is no y. Any questions on reorganizing? No? Okay, so we do have this polynomial divided by y minus 3. So with synthetic division, whatever you're dividing by, you got to do like a small piece of math here. We're going to take that y minus 3 that we're dividing by, and on the side, I'm going to set that equal to 0. And if I solve that, plus 3, I have y equals 3. And that answer, that 3 right there, is what's going to go inside this box. Or it's not really a box, but it's like a backwards capital L. So everybody put a little backwards capital L right there. And we're going to put that answer 3 right in that box. Okay? And now we're going to also make a list of numbers right here. And the list of numbers will be the coefficients of your standard form polynomial that's organized representing every single power. Now if you're thinking, what the heck, what language is he talking in? I'm talking math here. Coefficients, the number 2 in front of the y to the third, I'm going to write it right here. The negative 1 in front of the y squared, I'm going to write it right here. The 0 in front of the y, I'm going to write it right here. And the constant 25, I'm going to write it right here. And you put a line right here, and make sure that there's space between your number and the line, because we're going to be writing stuff in between this space, between the spaces of the numbers and this line. So this is the setup. This is the format. You put a backwards capital L. You set this equal to 0. Solve it. You get an answer. Plug in that answer right here. Get all the numbers in front of your variable terms. 2, negative 1, 0, 25. 2, negative 1, 0, 25. Put a line right here. Leave some space. Does everybody understand the setup? Okay? I know it's kind of weird, but trust me, you're going to love it. Now, this 2, you're going to begin with this 2, and as you go down, you combine. So this is what I'm going to do right now. For the sake of taking notes, I guess, we're going to zoom in a little and write down the word combine. As you go down, you combine. And notice, there is no number right here to combine. So that's like 2 plus 0. What is 2 plus 0? 2. Okay? Now, as you go up, you multiply. Now, what do I mean by that? You take this 3 right here, and you multiply it by that 2, and you put your answer up here. So right here, I'm going to write the word multiply. Okay? So it's kind of like taking notes, but as we're working this example, right? The 2 combines with nothing. 2 plus nothing is 2. The 3 multiplied by 2 gives us a 6, and I put that 6 up here. I put that 6 right here, right below the negative 1. I know it's weird, but trust me, you're going to love it. As you go down, you combine. So this negative 1 plus a positive 6, negative 1 plus 6 is 5. And then as you go up, you multiply. So 3 times 5 is 15. And the 15, you put it right here, underneath the 0. As you go down, you combine. 0 plus 15 is 15. As you go up, you multiply. 3 times 15 is what? 45. Put it underneath the 25. As you go down, you combine. 25 plus 45, 70. And I think, why do you write it in green? That last number right there, put a line right here. That last number right there will always be your remainder, okay? It's always going to be your remainder, okay? And these numbers over here, these red numbers, are technically your answer, believe it or not. Let me just show you how to write it. In order to write this answer, you have to look at the original problem. The original problem is a 2y to the third divided by y. So what would that be? Anybody? 2y to the third divided by 1y? What would that be? 2y to the third divided by 1y. 2y to the second, right? Yeah? And notice, there's a 2 right here. All we need to do is write the y to the second right next to it. So this is our answer. The 2y to the second plus a 5y plus 15. That's a constant, no y. And then the remainder is a positive 70 over the original divisor, y minus 3. I know, amazing. I know you guys are thinking, man, that's kind of confusing. Yeah, it's the first time you see it, you know, but it's like riding a bike. Once you do it a couple of times, you're like, man, this is cake. I don't need to think about pedaling. It's just gonna flow pretty easy. Once again, where do you get this number from? You take whatever you're dividing by, set it equal to 0. That's the number that goes in here. And then you take the numbers of your standard form. It has to be in order. You have to be representing every single power, power 3, power 2. There was no y to the 1, so I put 0. You got to represent them with 0. Even if you were doing long division, you'd still have to have that plus 0y. And then you make that list, and as you go down, you combine. 2 plus nothing is 2. And then as you go up, you multiply. 3 times 2 is 6. As you go down, you multiply, or combine. Negative 1 plus 6 is 5. As you go up, you multiply. 3 times 5 is 15. As you go down, you combine. That's why I wrote combine right here, because as you go down, you combine. As you go up, you multiply that. So I wrote multiply right there. This last number, when you combine, this last number will always be your remainder. Okay? And the final part is to actually write your answer. These numbers are the coefficients of your answer, but you gotta think of the original question, 2y to the third divided by y. That should be 2y squared. There's the 2. All it needs is the y squared, 2y squared. And then after that, you know what? You're gonna be going down from 2 to 1 to the constant to the remainder. And that's always gonna be true. If you kind of understand that, that's awesome, because it's the first one that you see. All right, let's take a look at another. Here's today's worksheet, part B, which is with synthetic division, dividing polynomials with synthetic division. So let's go for, how about this bad boy right here? Let's all copy that down. So on this question, we could do long division. I mean, if you love long division, go for it, but it does take a long time. That's why I call it long division, right? It's easier to do synthetic. So what number belongs inside this box, inside that reverse capital L? Positive 5, that's right. How do we get that positive 5? You set this equal to 0, solve. It's easy to see that, oh, plus 5, your answer's 5, right? 5 goes inside the box. Over here, we need a list of numbers of all the coefficients, the numbers that are in front of each term, but every single power has to be represented. Do we have any powers missing? No, right? We have 4, power 3, power 2, power of 1, constant. We're good. We don't need any zeros. So what's the list? 1, negative 3, negative 11, 3, and 10. Notice I don't put these numbers too close together, because then it gets confusing. You might look at it and see a 310. So leave some space between your numbers. And then when you make your line, leave some space between your line and the number itself, because we need to write things in here. Okay? And again, as you go down, you combine 1 plus, there's no number here, so 1 plus 0 is 1. And then as you go up, you multiply. 5 times 1 is what? 5. Okay? And then as you go down, you combine. Negative 3 plus 5, what do I get? Negative 3 plus 5? You owe $3, you have $5? 2. As you go up, you multiply. 5 times 2 is 10. As you go down, you combine. Negative 11 plus 10, negative 1. Now, you know what? Instead of me drawing the arrows, I'm just going to use my red dot here. 5 times negative 1, negative 5. As you go down, you combine. 3 and negative 5, negative 2. As you go up, you multiply. 5 times negative 2, negative 10. And line right here, remainder is 0. Beautiful, right? So what is our answer? If we look at the first term, x to the fourth divided by the first term x. X to the fourth divided by x. What should my first term be on my answer? X cubed, x to the third, right? 4x's, 1x cancels with 1x, x to the third should be our first part of our answer. So this 1 right here is a 1x to the third. 1x to the third. And then from there, it's just you just go down 1 power, down 1 power, down 1 power. So the next one's going to be plus 2x squared minus 1x minus 2, remainder 0. I'm done. There's my answer. I don't really need a 1 in front of the x to the third, or even a 1 in front of the x. I could have just left this x to the third and just minus x. It's up to you how you want to write it. Just know that. Anyways, there's your answer. What do you think? I mean, that's super fast and honestly way safer than long division. Long division, you're distributing that minus sign, you're combining terms. There's a lot of opportunities for mistakes. Right here, it's like very fast and safe, I would say. Synthetic division is awesome. That's barely the second one you've seen, right? So let's do some more so you can get more comfortable. You know what? I'm going to pause it right here, and I'm going to let you guys try it, and we'll see if we got the right answer. Then I'll explain it. Don't worry. Okay, so I did see a lot of you have the correct answer, so that's great. But let me actually demonstrate. Inside the box, I have a negative 2. The coefficients, the numbers, are 6, 15, negative 8. Notice that there's no y, so I need to represent that with the 0, and then at the very end, the negative 6. So once again, 6, 15, negative 8, 0, because there is no y, and then negative 6 at the very end. A line down here. As you go down, you combine. 6 plus nothing is 6. As you go up, you multiply. Negative 2 times 6 is negative 12. As you go down, you combine. That gives us a 3. As you go up, you multiply. Oh man, I got all my colors all messed up. Negative 2 times 3 is negative 6. As you go down, you combine. Negative 8 and negative 6 is negative 14. As you go up, you multiply. Negative 2 times negative 14 is positive 28. As you go down, you combine. 0 and 28 is 28. As you go up, you multiply. Negative 2 times 28 is negative 56. This is our remainder over here. The negative 6 and the negative 56 is negative 62. So technically, this 6 right here is a part of my answer, but I do need to think the first term, 4, or I can't even speak right now. 6y to the fourth divided by y. 6y to the fourth divided by y is going to be 6y to the third. So I have the 6. All I need is y to the third. So 6y to the third, and then after that, just go down 1 power on each term. This next 3 will be a y squared. The minus 14 will be with the y, and the positive 28 is just going to be a positive 28. And at the very end, we have minus a fraction, the 62 up on top, and the y plus 2, the original divisor, on the bottom. There's your final answer. That's done pretty quickly compared to long division. Yay? So I hope we're getting more comfortable with this. It's awesome. Check this one out. This one's fun. It is. Together now. Backwards L. What goes inside the backwards L inside the box? 4. How about the list? Could somebody give me the list of coefficients representing every single power?
A to the third.
Okay, just the number in front of the a to the third. 1. 0 because there is no a squared. 0 because there is no a. Minus 64. That's the last number. Okay, if you miss one of these zeros, it's going to be wrong. Okay, we need to get this. So here's our line. As you go down, you combine 1 plus nothing is 1. As we go up, we multiply. 4 times 1 is 4. As we go down, we combine. 0 plus 4 is 4. As we go up, we multiply. 4 times 4 is 16. As we go down, we combine. 0 and 16 is 16. As we go up, we multiply. 4 times 16 is 64. And this is our remainder. Negative 64 and 64. As you go down, you combine. That's 0. That's your remainder. And once again, go back to the original. A to the third divided by A. What's A to the third divided by A? A to the second. So this 1 should have an A to the second right next to it. 1A to the second, which means that the 4 is now going to have a regular A, and that 16 is just going to be a regular 16. And you don't need the 1 in front of the A squared. So there's your final answer. A squared plus 4A plus 16, no remainder. Fun stuff, huh? It's done really quickly, way better than long division. Should we do another, or what do you think? Oh, check this one out. This one looks like multiplication, but it's really division. You guys remember negative exponents? You got to grab it, move it to the other side. What other side? There's really a fraction, but that x plus 2 to the negative 1, when you move it down, it becomes x plus 2 to the positive 1. So that's really a division problem. So again, with synthetic, what goes inside the box? Negative 2. Give me the list of numbers that goes outside the box. 1, negative 3, 0, because there is no x squared, right? And then 5, and then negative 6. I hope we understand that setup, right? Highest power is 4. There's a 1 in front. There's a 1. Negative 3. It's right there. Where's the x squared? There is no x squared. You have to represent that with 0. In front of the x to the 1 is a 5 right there, and the constant is right there. Okay, so as you go down, 1 plus nothing is 1. As you go up, negative 2 times 1 is negative 2. As you go down, negative 3 and negative 2 is negative 5. As you go up, you multiply. Negative 2 times negative 5 is positive 10. As you go down, you combine. 0 plus 10 is 10. As you go up, multiply. Negative 2 times 10 is negative 20. As you go down, combine. 5 plus negative 20 is negative 15. As you go up, multiply. Negative 2 times negative 15 is positive 30. And right here is our remainder. Negative 6 and 30, that is 24. And that's our remainder. So what is our answer? It starts with x to the fourth divided by x. So what should our first answer have? 1x to the... If it was a fourth divided by x, it should start with 1x to the third. Wait, you guys don't sound too confident. You understand that, right? I mean, if you don't understand it, think about it. If you write it on the side, x to the fourth, that's what that is. Divided by x, that's what that is. Isn't it where this x cancels with one of these and you have x to the third left over? Right? You guys understand that, right? So that's why our answer is 1x to the third minus 5x to the second plus 10x minus 15, and then the remainder plus the 24 over the original divisor, x plus 2. I mean, we did that pretty fast, especially if you were to try to do it with long division. I mean, long division will take you twice, maybe even 3 times as long as this, all right? So I hope we're comfortable with synthetic division. So when dividing polynomials, you could use whichever method you want. You want to use long division, go for it, but it's going to take a lot longer, right? Synthetic division is the way to go, especially when you have something like x plus 2 that you're dividing by x plus 2, or you're dividing by x plus 5 or x minus 3. Like if this would have been x minus 3, what would be inside of the box? A 3, right? I mean a negative 3. If there were x plus 3, it'd be a negative 3. If it were x minus 7, it'd be a positive 7. So whenever you have x plus a number or x minus a number, all you got to do is synthetic for sure. Now, yesterday we did long division, but check out the problems from yesterday. Most of them down here had not just y plus 3, but you had a number out here, 2y plus 3, and that makes it weird, to be honest with you, in 2 parts of it. So on this one, students sometimes choose to do long division, but what I want to do right now is show you how we could use synthetic division even on these problems, all right? So let's take a look at this problem with synthetic division. What would be inside the box? Now this is where it starts. The first weird part is that right here, it's not a -3. Why not? Because this is not a y plus 3. If it were a y, if this 2 wasn't there, then yeah, a -3 would be in here. But because it's a 2y plus 3, this is what must happen. 2y plus 3, if you set that equal to 0, subtract 3, you're going to end up with 2y equals -3, which means that y equals -3/2. Are you with me? So inside the box, you actually have a -3/2. And this is where some students are like, oh, forget it. I don't want to deal with fractions, right? I'm just going to do long division. I'm going to turn off my brain. I'm not going to listen to Salgado right now, right? But keep your brain on. Pay attention. You might like synthetic division even in this more challenging situation, all right? What is the list of numbers? 6, -5, -15. All right, here's my line. As you come down, 6 plus nothing is 6. As you go up, you multiply -3/2 times 6. Now, you could use a calculator to give you the answer. But even without a calculator, it's as easy as this. Take the 6, take the numerator 3, or -3, and multiply them together. What's 6 times -3? And what is -18 divided by 2? -9. So this up here ends up being a -9. Okay? And then when you come down, -5 plus -9, -14. And then up here, when I go -3 times -14, that's -42. No, positive 42, because it's negative times negative is a positive. Then divided by 2, 42 divided by 2 is 21. So this is a 21 over here, positive 21. And as you come down, you combine. -15 plus 21, what is that? 6. And that's our remainder. Now, that was the first weird part. The first weird part is that you had to multiply with fractions. And you could get away with the calculator as well. The calculator could do that for you. The second weird part is this. Check this out. What is 6y squared divided by 2y? 3y, right? Now notice this is not a 3, but it needs to be a 3 because 6y squared divided by 2y is 3y. So this is the weird part, that these numbers, if you need to make this a 3, you'd have to divide these guys by 2. Okay, so if you divide by 2, it'll become 3 minus 7, but you don't mess with the remainder. The remainder is still 6. Okay? So yes, it's kind of weird. But so what is our answer going to be? We said 6y squared divided by 2y, that's 3y, so that's a 3 with a y. The minus 7 is the constant, and we know that the 6 is the remainder over the original divisor, 2y plus 3. So there's your answer. Two weird things about this situation. One weird thing is actually multiplying by the fraction. The second weird thing is before writing your answer, you got to look at 6y squared divided by 2y. We know that that's 3y, not 6. So you got to change this to a 3 by dividing these guys by 2. So 6 divided by 2 is 3. 14 divided by 2 is 7 with the minus sign. And this is how you get to your final answer. Don't mess with the remainder though. So if you prefer long division, go for it. If you want to do it a little bit faster, it's a little weird with the fraction, and it's a little weird at the very end when you know that 6y squared divided by 2y is 3y, and that's not a 3, so you divide these guys by 2 to get that 3y. Okay, let's try another. Another one. Again, we did this one yesterday. With long division. If you like long division and you're cool with that, you feel more comfortable with it, you could do long division, no problem. I actually in the past would choose to use long division on this problem, but since I'm trying to get more comfortable with synthetic, I'm going to force synthetic right here. Now normally, if you didn't have this 2, if it were just a p minus 3, oh man, for sure, just plug in the positive 3 right there and go. But we don't have p minus 3, we have 2p minus 3. So what is the value that's going to go inside the box? It's not positive 3, it's what? 3/2. Positive 3 over 2. Okay? Does everybody see that, or do you need to see that work right here? Just add, set it equal to 0. I'll show my work, why not? Set it equal to 0, plus 3 cancels. You end up with 2p equals 3. You're going to divide by 2, so p equals 3/2. So that's why we plug in a 3/2 in that box. So now that we got that out of the way, let me erase it to get more space. And let's go for our list. What is our list of coefficients? 4. 0. Good job. -17. 14. -3. Put that line. As you go down, you combine. 4 plus nothing is 4. As you go up, multiply. 3/2 times 4. Again, what is 3 times 4? What is 12 over 2? 12 divided by 2? 6. So we have a 6 up here. As you go down, combine. 0 plus 6 is 6. As you go up, multiply. 3/2 times 6. Again, top number 3 times 6. 3 times 6 is 18. 18 divided by 2? 9 goes right here. As you go down, combine. -17 plus 9. -8. As we go up, multiply. So 3/2 times -8. Do the -8 times 3. What's -8 times 3? -24. Divided by 2? -12. As you go down, combine. 14 take away 12. 2. As you go up, multiply. 3 times 2 is 6. 6 divided by 2 is 3. Or you could have canceled the 2 with the 2 and get 3 left over. Whoops. That should have been red. Sorry. As you go down, combine. -3 and +3 is 0. So the remainder is 0 in this case. Now, what's our final answer? It's not 4p to the third. It has to be what? What is 4p to the fourth divided by 2p? 4p to the fourth divided by 2p. 2p to the third, right? And notice this is a 4, but I want it to be a 2 because 4p to the fourth divided by 2p is 2p to the third. So I need this to become a 2. So what am I going to divide all this by? By 2, right? Or multiply by half, yeah. So you divide them all by 2. You're going to have 2, 3, -4, 1. And then you just put your p to the third right there, plus p to the second right there, -4, p to the 1, plus 1, and that's it. So yes, it's a little weird using synthetic division when you have a number out here in front. If it just said p minus 3, then inside the box you have a plus 3, for sure use synthetic division. It would be not smart not to use synthetic division. If you didn't have a 2 right here, if it was just p minus 3, put a 3 right there, handle business, right? But because there's a 2, it makes it weird. First of all, you get a fraction. Multiplying by fractions is kind of weird. Not only that, when you get to your answer, you got to think, well, that 4 divided by that 2 ends up being 2, and that's a 4, so I need to divide all this by 2 to get to your final answer. So it's up to you. If you like long division on these, go for long division. If you want to try synthetic, you got to do exactly what we did here. I don't know. It's up to you guys. Should we try another, or should we do one of these guys up here where you don't use synthetic or long division? This is just canceling things out. You guys want to try just canceling things out? So this one, number 2. We have the first term, 6k squared m over 2km squared minus 12k to the third m squared over 2km squared plus 9m to the third over 2km squared. All I did was take that denominator and put it on each of these, creating 3 fractions. If I separate it and look at it as one fraction at a time, notice that there's no addition or subtraction in here. I could just cancel things out. 6 divided by 2 is 3 up on top. 1k on the bottom disappears with one of these 2, leaving you 1 left up on top. 1m up on top cancels out with one of these, leaving you 1m on the bottom. The first term is 3k over a single m. The middle fraction, 12 divided by 2 is 6. This k on the bottom completely cancels out with one of these three, leaving you two k's left up on top. All two m's cancel with all two m's. So on the second fraction, I have a minus 6k to the second over nothing. So I could put over 1, or I could just leave it like that. And for the third fraction over here, 9 divided by 2, you can't do that. So it's still going to be a fraction with the 9 on top and a 2 on the bottom. But I could cancel out m's. Both m's on the bottom cancel with 2 of the 3, leaving you 1 m left up on top. So we do have an m left up on top and a k on the bottom. And this is your answer right here. By the way, that green fraction is a positive. So that's your answer for number 2. So that's how you would handle the first 6 questions of this worksheet. The second half of this worksheet, I would recommend using long division, or if you want the new method that we learned, synthetic. But I know some people don't like synthetic when you have a number out here in the front. So if you're cool with synthetic, go for it. If you're not cool with it, then go back to long division on these. But again, if you do have just y plus 3, just y plus 3, for sure, do synthetic division. It's really easy.